To learn more about the Sun, India's first mission is Aditya L1, for which ISRO used a large version of the PSLV. This mission is ISRO's gift to humanity, as it will provide more information about the Sun's environment. In the first stage, 4 PSOM booster engines, which run on solid fuel, and the main rocket engine are ignited. A little after the rocket begins its flight, the remaining 2 PSOM booster engines are also started. Each PSOM booster engine contains about 12 tons of solid fuel, while the main rocket engine uses 19 tons of solid fuel. After burning, first 4 and then the other 2 PSOM booster engines are separated from the rocket. Then, the main S-19 engine from the first stage is separated, and the second stage, which uses liquid fuel, is started. The protective cover, or shield, for the satellite and other equipment is separated from the rocket, because at an altitude of 113 kilometers from Earth, the air becomes so thin that it no longer affects the rocket. The third stage begins at an altitude of about 130 kilometers from Earth, and its rocket engine is made with solid fuel. In the fourth stage, there are 2 rocket engines that run on liquid fuel, which are turned on or off to control the rocket's speed. By doing this, the satellite is freed from Earth's gravitational pull and sent toward Lagrange point 1, or L1 point, which is about 1.5 million kilometers away from Earth. This is why the mission is known as the Aditya L1 mission. Having traveled from Earth, Aditya L1 has now reached Lagrange point 1. This is where Aditya L1 will stay to study the Sun and fulfill its objectives. From Lagrange point 1, the Sun can be continuously observed without any interruptions, and changes on the Sun's surface or in its atmosphere can be constantly monitored. After reaching Lagrange point 1, Aditya L1 starts to deploy its instruments so it can begin observing the Sun. Aditya L1 has 7 different instruments to help it observe the Sun. Information on how the Sun's surface and solar flare activities affect the magnetic field at Lagrange point 1, and what the composition of solar winds is, will be collected by a satellite on Aditya L1 and sent to Earth. Solar panels will generate the necessary energy for Aditya L1 to function. The Moon is 384,400 kilometers away from Earth. There are 5 Lagrange points in the Sun-Earth system. Lagrange points are special locations in space where the gravitational forces of the Sun and Earth are balanced. Any object placed at these points experiences an equal pull from all directions, which keeps it stable at that location. This stability is due to the mutual interaction of gravitational attraction from both the Sun and the Earth. Anything placed at a Lagrange point remains stuck there due to this stable balance. These Lagrange points are very important in space exploration. Just as the Earth orbits the Sun, all Lagrange points, and any object placed at them, also orbit the Sun. This is why Aditya L1 was sent to Lagrange point 1. so it can stay stable and observe the sun without any interruptions. After reaching Lagrange point 1, Aditya L1 starts to deploy its instruments so it can begin observing the sun. Aditya L1 has 7 different instruments to help it observe the sun. Information on how the sun's surface and solar flare activities affect the magnetic field at Lagrange point 1, and what the composition of solar winds is, will be collected by a satellite on Aditya L1 and sent to Earth. Solar panels will generate the necessary energy for Aditya L1 to function.